Hello and welcome to the AMCI tutorial. With this tutorial, we assume that you already know how to add an AMCI drive to a PROFINET network. If you have any issue with this procedure, please refer to our tutorial that explains how to add a drive to a PROFINET network. So in this tutorial, we will talk how to perform some basic moves with an AMCI stepper drive that resides in a PROFINET network. For this tutorial, we will use this SMD23 stepper drive as an example, and this tutorial is applicable for all of our networked stepper drives. These are the topics that we will cover in this tutorial. Downloading the sample programs with the library, configuring the stepper drive, adding components from the library, compiling and downloading the project to a PLC, and finally performing basic moves. It is recommended to download a zip archive file that, besides sample programs, contains a library with many functions and data blocks, which will be used in this tutorial, and it will definitely make your programming efforts easier. In this step, first we're going to open the library, then select needed components from the library that we're going to need for this tutorial and add them to the project. And then we're going to pick one by one of those components and add to a program. Then on the end, we can compile and download the project to the PLC. I have opened a new project with already added PLC, also established the PROFINET network, and added the SMD23 stepper drive as an example for this tutorial. I'm going to briefly open the properties and show the configuration parameters that's going to be used for this tutorial. I'm going to keep all of them as default values. The only thing, maybe I can change the motor steps per turn. I'm going to change to, let's say, 4000, just to be some round number. Okay, so next thing, I'm going to open the library and take all the necessary components from the library to build our program for this tutorial. You can go this way too, or you can even open just the sample program and modify to your needs, or even you can combine both of them, open the sample program, and if you need some extra functions, then you can go to library and take them from the library. So click on the libraries tab and then open the library. So you have to find the place where you downloaded and saved the library and open it. So you can see there are 4 folders for different components. The first one contains the data blocks. There are 3 of them, and we're gonna use only 2 of them for this tutorial. So there's the input data block and output data. Input data block gonna contain all the data that we are reading from our unit, from SMD drive, and output data is gonna contain all the data that we want to send to the server, to the stepper drive. So I'm gonna select both of them and simply drag and drop to the program blocks folder. Next, functions folder. You can see all the functions available. Also, I'm gonna select a few of them that we're gonna need for this tutorial. Absolute move, jog moves, then preset motor position. That one we're gonna need for the absolute move. Then gonna select the relative move, stop drag move, and right. Okay, I'm gonna repeat the same thing, just drag and drop to the program blocks folder. Also, I have that PLC tags predefined, so that's gonna make the programming much easier. Also, you can take those tags and redefine to your needs. So I'm gonna grab and drop to the PLC tags folder. And also I'm gonna add this watch table. I will call it control table, also to the watch and force table. Okay, so I believe we have everything what we need for this tutorial. I can even close the library. So the next thing, I'm gonna open the main program. And what we need, first thing, to read the data. So we need to read the data from the SMD23 stepper drive. All our drives belong to the distributed IO. So from that, I'm going to open that folder and find the functions, or rather instruction, that going to read the data. So under the others, you can see there are two functions, dp read and dp write data. Both of them we're going to use it, one for the reading, another from the writing to the unit. So this time I'm going to grab this one. You can see there are three parameters that we have to add and define. So this is over here, you have to point out to our unit where is the data supposed to be read from. So when you click and scroll down, there is the so-called hardware ID. So as you can see, the SMD23 20 bytes in. So select that. On the other side is an output. There's the record. So basically we have to say where we want to record or store the data. As I said before, we have that imported input data block. So I'm going to select that. And there's the return value for this instruction. I also have that tag. So this value is supposed to be 0 when these functions executes correctly. That value should be 0. In case any errors, you're gonna have some hexadecimal like error code. Also, we don't need any condition. We want this instruction be executed at every scan. So basically we need to update every scan what's happening with the unit. Also important to say, this instruction, this particular instruction is used because it reads a consistent data. What it means? It means we need to read 20 bytes of the input data. So when this instruction is executed, it preserves all 20 bytes and it's read without any interruption. So that's importance. So next thing, I'm gonna grab, let's say, a preset motor position function. This one has only one input parameter. So basically you have to say at what position you want to preset the motor. Then for this function we need some condition, because we don't want to be executed all the time. Just like in a sample program, I'm gonna use that control tag and just giving different values for that control tag. So that's how I can control what function gonna be executed. So I'm gonna go to the compare and this, drop it here, and then control. And let's say when control has a value of 2, this function is going to be executed. Of course, you can replace this condition with anything that is more suitable for your case. Next, let's say I'm going to drag and drop the relative move. Okay, we have a little bit more parameters for this one. So input parameters, of course, that's target position, program speed, acceleration, deceleration, and so on and so forth. As I said, now it's come handy that the tags, predefined tags, so simply I can find, let's say this is the relative move target position, then relative program speed, then acceleration, deceleration, standard or indexed move, and finally acceleration jerk. Okay, so we have all inputs, and also this function generates 3 outputs. So basically every time when it's executed, it monitors also the 3 possible errors, either input error, command error, or configuration error. If any of it happen, it's gonna set those corresponding bits. So I'm gonna set this the input error, command error and configuration error. Okay, and of course we need for this function also some condition, so I'm gonna use the same one. And then let's say I'm gonna put it when this value is 3, the relative move is gonna be executed. Okay, so I'm gonna keep adding all the rest of the functions, and then after that we're gonna be ready to compile and download program to the PLC and execute some moves. Now I finished adding all the rest of the functions. You can see, so the last one was the relative move. Also I added the absolute move, and just populate all the input and output parameters like a target position, program speed, and so on and so forth, and the same set of the outputs, basically just those monitoring those errors. So their jog move clockwise and jog move the counterclockwise direction, and also the function, that one simple function is gonna stop the jog move. Also I'm gonna quickly open that a write data function just to show you. So see, you can use that DP write data. So it's very similar like a DP read data. We're reading record from that a command output data. So we fill all the data that we need to send to that data block, and then just use or just let's say call this instruction to send the data to our unit. You see over here there's the hardware ID for the output, so SMD23 20 bytes out, and also this one has its own return value. Okay, so I'm gonna go back and open here and then simply compile the configuration and then download all thing to the PLC. So I'm gonna compile it. And then I'm gonna download to the PLC. Okay, so now I'm gonna go online. Okay, everything so far looks good. The PLC communicates to our unit. So I'm gonna briefly open now that data block that's supposed to contain that data that is read from the unit, and just simply go online. Now you can see all the input data that we are reading from our unit. Input data consists of those 10 words or 20 bytes. So first two words are status words. So two status words basically consisting of the status beats. So all those two words altogether 22 status beats. So as you can see in this data block, input data block, we have all those 32 status bits tagged one by one. So basically if you need to monitor any of those status bits, simply you can grab any of those tags and use in your program if you need to make a decision upon the status of that particular status bits. So for example, the status bits of the heartbeat turning on and off, meaning that our unit communicates and it's so to say it's alive. Then for example in position invalid bit is true. The reason is we have just powered up our unit, we haven't homed it or haven't preset the motor position, so that's the reason it's true. Both of those actions would turn this bit to be false. Next, for example, module OK is true. We don't have any errors, input error, command error, configuration error. They're all false. It's supposed to be. The unit is stopped, and so on and so forth. So as I said, whenever you need to monitor any of those bits, simply grab them from this data block. And also after those status bits, there's the motor position, encoder position, capture encoder position, and so on and so forth. Okay, so I'm gonna go offline and close it. So now we are ready to perform some moves. So at this point we should be able to perform some basic moves like relative move, absolute move, or a jog move. So now it's time to finally do some moves. So for that purpose I'm gonna open that watch table that I also imported from the library. So over here I already have some tags that we're gonna need for this tutorial to perform those basic moves. First I have that control tag. As I said, I'm gonna use that like in a sample programs to decide what functions gonna be executed, or in this case what move gonna be executed. So for example, if control is 2, it's gonna be preset motor position. If it's 3, it's gonna be running relative move, 4 for absolute move, 5 for the jog clockwise move, 6 for jog counterclockwise move, and 7 for the stop jog move. Also I have all those tags that are organized by type of the move. For example, I have over here all those tags for the absolute move, so we have to enter the values for them. Then for the relative move, for the jog move, and those are common to selecting either standard or index move or acceleration jerk. Also on the end, or rather on the bottom, I have those two tags from the input data block. So this is the motor position. We're gonna monitor data position, and also that position invalid beat I can put just to monitor that beat too. Okay, so I'm gonna go online to monitor them, and when we need, we're gonna change them. So you can see right now the position is 0 because we just power up the motor. The position invalid, as I said before, it's true for the reason that we haven't homed or preset the position, but that beat doesn't matter if we want to perform jog move or even relative move. The only importance to get it false only if we want to perform absolute move. So we're gonna do it later. Right now we can start with a jog move. Over here, related for the jog move, so the program speed, let's say I'm gonna start with 5000 steps per second. Then acceleration, deceleration, let's say I'm gonna put both of them simply 500. Okay, then also over here I'm gonna use, for all moves I'm gonna use the standard move, and even though it's already false, I'm gonna select to be set anyway. And also acceleration jerk, we're gonna keep it 0, what is also just default value. So now I'm going to go back to control and set, for example, for the clockwise jog move is gonna be 5. So I'm gonna enter 5 and send it. And as you can see, the motor moves with that program speed in clockwise direction. Also, I can change the speed on the fly, so to say. So I can change, for example, from 5000, let's say 7000, and just send again command. As you can see, the motor speed up. Then I can go, let's say, to lower speed, let's say 44,000, and it's gonna slow down. To stop it, I have to enter the 7 in the control tag, so it's gonna stop. Then in order to move the counterclockwise direction, I'm gonna simply enter the 6, and the other function is going to be executed, and you can see the motor moves in the other direction. Also, if you want, you can change the speed. For example, I'm going to put it back to 5000, and you can see it changes. So as I said, basic jog move is very simple, straightforward. I'm gonna stop it. Okay, so the next thing I'm gonna do relative move and absolute move. But before, anyway, I'm gonna preset position to 0. Just you can see later on easier when we change the position or to from one position to another position, so you can see how much the motor goes back and forth. It's easier to monitor. So I'm gonna use 0, so I'm gonna preset to 0 and then use enter number 2, and you can see the position is preset to 0, and then we have that in position invalid bit is now false. Okay, so let's say I'm gonna do the relative move. For example, I can put 40,000 steps. Velocity or speed I can set to, let's say, 5,000. Acceleration 4000 and deceleration 1600. Okay, and I'm gonna select, or rather enter 3. That's gonna be executing relative move. So now when we execute relative move, the motor positions should end up with 40,000, as much as we asked to go. And here it is. So we asked to go to relative move 40,000, it goes 40,000. Let's say we want to go another, let's say 20,000. So I'm gonna simply start relative move again. Now it's gonna go additional 20,000 to 60,000 counts position. Or if we want to go back, let's say I'm gonna go back to, I'm gonna put that minus 30,000. So it's supposed to go in opposite direction by 30,000 counts. And you can see now it's going into opposite direction and stops at 30,000. So simply, if you put the positive value, it's going to go clockwise direction. If you put the negative value, it's going to go in a negative direction, or rather in counterclockwise direction. Okay, so next thing I'm gonna use the absolute move. For example, now we are at 30,000. Let's say I want to go to minus 10,000 position. So now we have to put exact value. Do unit to go. Program speed, let's say 5500, 500 and 700. Okay, so this is the absolute move. So unit now is supposed to go to this exact position minus 10,000. Of course, now I have to change. So 4, I have enter 4, and you can see unit goes back and it's supposed to stop at minus 10,000 position. And here it is. So I can combine. For example, I can put over here, let's say 50,000 and execute a relative move. So unit is gonna go by 50,000, so it should end up at 40,000. Okay, and then let's say we want to go back to 0. I can put 0, so absolute value 0, and I'm gonna executing absolute move. So I need the 4. And it goes back to 0. So as you can see, relative move, absolute move, jog moves, everything works fine and relatively easy. So this tutorial shows that performing basic moves with the AMCI stepper drive is one fairly easy task, particularly when using our sample programs and or supplemented a library. Thank you for watching this tutorial. Should you have any question, please contact us and we will be more than happy to help you.